share ಮಾಡಿ
yes sir. Sir, enter screen ಕೊಡೋದು.
Fantastic.
Visible ಇದೆ. Okay. Start. Very good morning, students. Myself, Parameshwar Bankar, from the Department of Aeronautical Engineering. Hereby, I welcome you all for the introductory sessions of an open electives. So, from the Aeronautical Department, or we can say Department of Aeronautical Engineering, this time we are offering an open elective that is called as Introduction to Aerospace Engineering. So this is basically the subject where all department students can opt it and they can study. And the syllabus, or we can say the subject, is having 90% of theory part and 10% of problems will be there. That is small problems related to each units. So here in front of you, I am sharing the syllabus, and I will go through the syllabus and tell you what and all you will be studying, and what are the course learning objectives, and what may be the outcome, and what textbooks are available. Okay, and finally the format of SEE and CIE examinations. As you can see on the screen, the course code of the subject is 18AE 6611, and it is a 3-credit course which is having the CIE marks of 50, and SW marks will be there, and total hours will be 40 hours. And basically this subject is, what we can say is like, any department students can opt it, as I said before, because some people may be interested to know what things are going in the aeronautical department, what their aeronautical students are studying. Okay, so in order to just give you the introduction about our subjects, our department, we have introduced this syllabus where you can pierce through it as well as explore the things which students can learn in the Department of Aeronautical. So basically it's having 5 units as usual, and each unit will be dealing with each stream of the aeronautical engineering, and there it will not be there in depth, but it will be in surface level, so that you will get to know how an airplane will fly, and how the aircraft engine will work, and what are the control surfaces of the aircraft, and how the structural parts will be behavior, and also you will study about the performance and stability of the aircraft, how to control it, and which are the parameters will affect the performance of the aircraft. All those things you will study, but everything will be at the surface level. And here the course learning objectives are like this. Here you will understand aerospace vehicles and its components. There are various aerospace vehicles are there, and they have got their own component. Each component will function differently, how they will work. That's what you are going to study. And here you will understand the basics of flight principles within and beyond atmosphere. If an aircraft should fly, how it will fly, what are the principles behind it, how the lift will be generated, and how the drag will drag the aircraft backside, and how to overcome from that. All those things you are going to study or understand in this particular subject. And the third course learning objective is describe the various propulsion systems of aerospace. For an example, if you take a bike or car, or we can say a truck or lorry or bus, it has got its own engine which will produce the power so that your vehicle will move forward. Similarly, we have a propulsion system at our aerospace domain, so that how the aircraft will fly, how it will produce the power required for the aircraft to fly in the air. So similarly, that rockets are there, how they will fly, what is the reason behind that, how the engine will work. All those comes under propulsion system. That also it is there in this syllabus. And the fourth course learning objective is stability and performance parameters of aerospace vehicles. You will get to know here how to maintain the stability of the aircraft, and how the parameters will affect the performance, which parameter will be good for good performance, and there are some parameters which will pull down the performance of the aircraft down. So which are they and how to overcome from that, that is also is there. And finally, the last unit basically deals with the vehicles which are related to space and satellites. Space and satellites are nothing but what we can say like the vehicle which will move into the space, that is rockets, okay, and maybe the satellites and other things. So basics of those vehicles, we call them as a aerospace vehicle. So about that also you will study. So these are the 5 course learning objectives we have got here, and each objective is related to each unit. Okay, the first unit you can see on the screen that deals with introduction. So history of aerospace you will study right from Wright brothers to today's era. So how the development of aerospace industry has taken place. And here also you'll study about aerospace vehicles. There are various kind of aerospace vehicles are there, and there are components of the aircraft will be there, as well as the rockets and how they functions, and how to control the aircraft, which are the parts of the aircraft can control the aeroplane. For an example, your vehicles, you might have having the brake, clutch, and accelerator. So using these 3 you can control your vehicle. Similarly, we have got so many control surfaces in the aircraft, and you can control your aircraft through that, and which are those control surfaces and how to operate them, and all that you are going to study here. And then here we are going to introduce or give the introduction about Indian aerospace sector, and which are the major aerospace industries are there and manufacturers are there, and what are the material technology they are using nowadays. Modern material technology what they are using in detail we are going to look at here. And then we have got the second unit, that is flight principle. Is that it is basically it's about the aerodynamics of the aircraft. So how the air will flow over the wing, how the lift will be generated, and how to nomenclature the aerofoil section will be there, and how it will what we say the impart the energy required to the aircraft to fly. All those things you are going to study in the second unit, that is basically about the aerodynamic part of the aeronautical engineering. Coming to third unit, as I told you, it is about the propulsion. That means the various engines of the aircraft we are going to study. We are going to classify them, and also we will see the working principle of each and every engine, and what is the basic principle behind that, how it will produce the thrust and everything. And finally, we have got some rocket engines, ramjet, scramjet engines are there, which are not like our air breathing engines. They are a little different. That also you are going to study. And the fourth unit deals with performance stability of the aircraft. So that means how the performance of the aircraft can vary with respect to the various parameters, and what is the stability part of the aircraft, how it will be maintained its stability, how it will maintain its stability, and which are the what we say the control surfaces will contribute to maintain the proper stability of the aircraft, and how the military aircraft will be having the stability, and our civilian aircraft, and even missiles and rockets. So all these things comes under unit number 4, that is the stream called as performance and stability stream of an aeronautical engineering. And finally, the fifth unit is the launch vehicles and satellites. As I told you, here you are going to study about rockets and satellites, and they're like how the rockets will work, as well as what are the materials they are going to use, and what you mean by orbit, and what are the future challenges in aerospace engineering. That also we are going to concentrate here and study about that. So these are the 5 units you are going to study, and this is the brief introduction. So once you get into the what you say the elective subject, you'll learn in detail. So there are some textbooks available for this particular subject, that is Introduction to Flight, written by John D. Anderson, and there is a rocket and spacecraft propulsion is there, that is written by Turner. So these are two textbooks we have. Similarly, reference books are there. One is Rocket Propulsion Element, written by Sutton, and another is Understanding the Flight, that is again written by Anderson DF, and one more is the Eberhardt S. Okay, so these are the textbooks which are required for the syllabus. And if you want to go for course outcome, once you study this syllabus, you're coming with this course outcomes. One is you'll understand the current trend of aerospace engineering, and you'll apply the basic physics in understanding the principles of vehicles, and you'll apply the laws of motions to the propulsion systems, and you'll apply the fluid mechanics concepts to understand the aerodynamics, and you'll understand the working of aerospace vehicles and satellites, and also you will understand the application of aircraft and aerospace vehicles. So these are the few course outcomes of this particular syllabus. So this is about the syllabus I told you, and it has got CIA like this. As usual, it will be having two IAs which are having the 30 marks each, and two assignments will be there, 10, and quizzes will be there. Quizzes will be 5 marks each. Quizzes, 10 marks quiz will be there, and then course project will be there, or we can say course activity we have. It is similar to your previous whatever the CI components are there. The same way it will be there. There is no much difference, and as usual, SW will be there. So this is about the brief introduction about of our open elective, that is introduction to aerospace engineering. So here the students who are really interested to know about the aeronautical domain, okay, so you can opt it. And as I told you, this is a surface level subject, and here 90% of theory will be there, and 10% of small problems can be given in the examination. Okay, so this is about the syllabus introduction. So later on, if you really wish to take this, you can opt for it. Thank you. Switch over.
Good morning, all. My name is Adarsh Krishnamurthy. So today I'll be discussing with you about an open elective called Unmanned Aerial Vehicle. So just let me open the syllabus. So from the aeronautical department, this is the second open elective that we are offering, and this is specifically based on the understanding of unmanned aerial vehicle, and the domain here would be the basic understanding of this subject, and also the advanced concepts of control theories and all, just the introduction for those concepts. So I will just go through the course learning objectives. So in here, the first course learning objective is to comprehend the basic aviation history and UAV systems, right? So you need to have a good understanding of the history of aviation, and in specific to be UAV systems. And the second one would be to acquire the knowledge of basic aerodynamics, performance, stability and control of the UAV. And the third course learning objective is to understand the propulsion and the structural components of the UAV. And finally, we try to understand the importance of controller design of an UAV. So it is very important not only to do the analysis and understand the concept, but also to come out with a practical knowledge of how an UAV is built and the related components. So that is the main aim of the particular course. So now we will go unit wise regarding the syllabus. So in the first unit, we have the aviation history and the overview of UAV system. So here you will understand the basics and how it all started, the dream of flying, and then slowly the concept, the idea of airplane got converted into an unmanned aerial vehicle. So it's very interesting to understand the history, and that will lead to the development of new designs in the current state. Then we will move on to the classes and missions of UAVs. So what are the different types and categories in which you can categorize the UAVs, and then different types of missions where you can use the UAVs. And then we will see some definition and terminologies. Then we'll move on to the UAV fundamentals. What are the building blocks of the UAV? And then we will see few examples of different types. Let's say, for example, small and very small, medium, and large UAVs. So this we will roughly cover in 8 hours. Then we will move on to the second unit, that is the basic understanding of aerodynamics. Now, aerodynamics is very important to study the machines that fly in the Earth's atmosphere, and the study of this is broadly termed as aerodynamics. The aeronautical students, they do have a separate subject, but for others, those who opt for this open elective, we will go through the basics and fundamental equations, what makes the UAV to fly, what all the properties that we need to consider while designing the UAV, and for specific missions that we will study in this particular unit. And then slowly we will move on to the aircraft polar, and this is where the performance comes into picture, that is the UAV performance, right? So then we will also study about the types of drag, which is very important since we are designing the UAV and understanding its working. So we should also consider how to reduce the drag, and this is where we understand different types of drags that are involved in the UAV system. Then we will give a brief introduction about the boundary layer, and also we study about the flapping wing mechanism. So right now, these are termed as the micro aerial vehicle, and in India and abroad, a lot of research is being going on in this area, and many startups are there with this idea of flapping wing, right? So that also we will study. And moving on to the performance, we will see the climbing flight, the range and endurance. Range means with one charge how much distance the UAV can cover, and the endurance tells about the time the UAV can spend in air without recharging. So these two parameters we will study specific to the UAV, and later on we will move on to the general performance parameters for propeller driven aircraft and jet aircraft. I think we will also add the electric aircraft here in our course. Then we have the gliding flight as well. So this will give a brief introduction where there is no engine power involved in the flight. So that is unit 2. And moving on to unit 3, we have the stability and control of the UAV, right? So once you understand the aerodynamics and the performance parameters, we will move on to the stability and control. These are very two important parameters while designing a UAV. And here we will go through about the stability parameters, which includes the 3 different types of stability, that is longitudinal, lateral, and dynamic stability. Here we will study about the static. Dynamic, we will give a brief introduction about it. Then we will try to understand how aerodynamics plays a very important role in stability of an UAV, and how to control its pitch. So what all the lateral controls available. Also, we will discuss about the autopilots and various types of sensors used in the UAV, and controller, actuator, airframe, and inner and outer loops. So in this unit, you will get a rough idea about how UAV works, what all the components involved, and finally all this, how it affects the stability of the UAV. So that part you are going to study in this unit. Then we will end the third unit with the introduction to flight controls. Okay, so what are the flight controls available in today's market and how you can utilize it in your design, so that we are going to understand. And modes of operation, right? What are the sensors that supports the autopilot system? And there is a case study. I think we will call an expert in UAV for this case study, where we will discuss the flight PID control designer for a 6 degree of freedom UAV. Right? So this will be an interesting topic to understand. So, and there is a self-learning topic as well in this, where you study about the sensors that supports the autopilot, right? So DJI and all the latest drone Parrot, so all of them, they are having this autopilot support, and recently the research is being shifting towards the autonomous flight. So here we will give a brief introduction about what all the different types of sensors that are used in the autonomous flights. So that is self-learning topic. So we will try to make it more interesting and creative in this self-learning topic. So moving on to the fourth unit, we will move on to understand the mission planning and control, right? So what is a UAV? What are the payload capabilities? How you are going to control the payload? What are the different types of applications? For example, reconnaissance and surveillance payloads, right? How you can use it and the design of payload. So all these things we actually students are developing a project on all the topics what we are discussed here. Then we will move on to the payloads, weapon payloads, and there are other types of payloads. For example, drone delivery systems are there, medical emergency supplies are there. So there are different payloads that we will be discussing in this unit. And then we'll move on to the communication part. So FANET, a lot of communication aspects we are going to discuss. So this electronics and electrical students can relate with their area of study, and then develop systems for UAV. So we will study about the data link functions and its attributes, and the data link margin, and the displacement autopilot, pitch orientation control system. So when you see a DJI drone that is hovering at one place, so a lot of algorithms and flight control systems are working in the background to not destabilize it during the flight, even though there are wind gusts, right? So these are all the things we will be studying in unit 4. And finally, we will end unit 4 with the acceleration control system, right? So moving on to the unit 5th, unit 5 is a most generalized unit, where you will study about different types of materials used in different types of engines, and currently what all the materials that are used in the UAVs, and related to the structural part. So we will end unit 5, and the total number of hours for the all the 5 units is just 40 hours. Okay. So there are few books that are given for your reference. So that is, one is Introduction to UAV Systems by Paul Guerin, and another is UAV by Landon Rawson. So there are different reference books, and in our library also there are a lot of books that are available. So moving on to the course outcome. So this is what is expected once you complete the course. The first course outcome would be to interpret the mission planning and control of the UAV. The second is to understand the basic aerodynamics, performance, stability, and control, specifically for unmanned aerial vehicle. And the third would be to select the propulsion system and material for structures. And fourth would be to apply the basic concept of control theory to design the controls for UAV. Right. So the course delivery methods would be most of the time the presentation and the problems, and also definitely videos. And the scheme of evaluation would be for 100 marks. The total would be 100 marks, and SE is for 50 and CIE is for 50. Right. So this is a brief introduction about the unmanned aerial vehicle. So those who are from computer science, electronics, electrical, and even mechanical, they can opt for this particular open elective and gain knowledge. And I would suggest, if you are very much interested into the understanding of unmanned aerial vehicles and its application, so they only should opt this, and definitely you can get a better understanding, and you may possibly design a UAV at the end of this course. Thank you.